Welcome guys to Thursday's lecture. So far we've learned about geologic time, specifically about rock records and fossil records. Today we will go a little bit further and talk about geologic time scale. So like I said, geologists kind of have to fast forward the entire Earth's history, look at it in a fast forward manner because of how vast and how wide it is. Um, and to help with that, we have something called the geologic column. So the geologic column kind of represent the billions of years that have been passed since the very first rocks were ever formed on Earth. And as you know, Earth is approximately 4.6 billion years old. So geologists actually try very hard to study all 4.6 billion years of Earth's history, and to make their jobs easier, they have created the geologic timescale. Excuse me. So geologic timescale is literally the scale that kind of divides the Earth's 4.6 billion year history into several distincts of time. Now, if you look over here, you can see the time scale. We have something called eons, eras, periods, and there are several under each category. For example, the Phanerozoic eon has three subcategories called the Paleozoic, Mesozoic, and Cenozoic. And then they are further divided into several periods like Quaternary, Tertiary, Cretaceous, Jurassic, and so on. So let's look at some of these. So of course, geologists have divided the Earth's history into sections of time. And we are interested in four of these sections. The largest one is called an eon. Now, in the previous picture, we just saw the eon here, the Phanerozoic eon, and we have the Precambrian eon. All right. So this is the largest division of geologic time. They are kind of like the big group that have a lot of subgroups or smaller groups within them. And the Phanerozoic era, like we just saw, is then further divided into three eras. So era is a subcategory of eon. So yeah, so the Phanerozoic eon is further divided into three eras. And eras are the second largest division of time, of geologic time. And those eras are then further divided into periods, which are the third largest divisions of geologic time. And periods are finally divided into epochs. Epochs are the fourth largest division of geologic time. As you can see here, we can't see the epoch here clearly, but we have the eons. We have, this is the biggest one. This is kind of like overlooking all of these here. Then we have the era. This is the second biggest one, subcategory. And then we have periods, which have more subcategories. And then we have epochs. Now, the boundaries of geologic time intervals kind of represent short intervals in which visible changes took place on Earth. We are talking about changes like disappearance of index fossils. Now, if you remember, index fossils were used to represent a specific or only one geologic time. So if they've disappeared, it's a visible change. It can also be, some studies cannot exactly be visibly marked, so these probably would only be recognized by detailed paleontological studies. Now, when we talk about appearance and disappearance of species, at certain times during Earth's history, the number of species have definitely increased or decreased dramatically. And an increase in the species normally happens as a result of a relatively sudden increase or decrease in competition among species. For example, now if there were five chickens and five, let's say hyenas or vultures, they would probably, okay, let's forget about hyenas or vultures. Let's say there are five sheep and 10 lions, right? So lions will definitely prey on sheep, right? They will make sheep their food. So the species of the sheep will start to go extinct because there is such an overwhelming population of lions when compared to sheep. On the other hand, if there's only one lion and 10 sheeps, then you could say that the population of sheep would actually thrive since they don't really have much of a threat, right? So certain factors like these kind of like affect if there's an increase or a decrease in certain species. Now, hallucigenia actually is something that appeared in the Cambrian period when the marine species greatly increased. This is one example. On the other hand, number of species decreased dramatically over a short period of time during mass extinction event. Mass extinction is basically when all the members of a species die or go extinct. So, of course, if all the species go extinct, there's going to be a dramatic decrease in the number, right? Events such as a global climate change can actually cause mass extinctions. And that is all we're going to talk about today. For example, let's see, if there was an ice age out of all of a sudden, there would be a good chance that a lot of species on planet today will disappear, will go extinct, especially in tropical areas where plants and animals kind of need the heat to survive. So such huge climate change can actually have a huge impact on the survival. Similarly, if the polar regions of the earth started getting hotter and hotter, to the extent that it was almost becoming tropical, it's very much possible that penguins in Antarctica will start to go extinct because they cannot thrive in that temperature. So, yeah, I hope this helps you guys, and this is all the content I have for you today. I hope you guys have a great day, and I will see you later. Bye.